Hello, boys. Welcome back to our online class again. It's my glad to have classes with you again. It would much better if we could have classes on our classrooms, but at this critical condition, we have no alternative to online class. So we will try to continue in this way. And as we were reviewing our chapters again, as you have finished all the chapters and you have given some exams on the specific chapters, your next exam, that means on pre-test exam, you have to cover the full syllabus, full book, and you have already notified that you have to give some in-house model test. On this context, we will try to review all the classes as early as possible. And today I will try to focus on chapter 5, state of matter and pressure. In today's class, I will just discuss some important topics and equations that are necessary for your creative type questions, and then we will just try to focus on some creative questions. So first of all, the first topic of this chapter is pressure. The force exerted perpendicularly to unit area of a body is called its pressure, and the familiar equation for this pressure is P equals F by A, where F is force and A is area. According to our equation, the unit is Newton meter inverse 2, or the usual unit that is used for measuring pressure is called Pascal. Its dimension is ml inverse 1 t inverse 2. Most of the time I just say in class that from a unit or dimension related one question is obvious for your multiple choice, multiple type question. So whenever you are trying to know about quantity, you just have to know its unit, its dimension, and whether it is a vector quantity or scalar quantity. So as it is a quantity, it is a scalar quantity, though we are dividing force, that is a vector quantity, by area, that is also an vector quantity, but the pressure is a scalar quantity. Then another topic is density. You already know about what is density. The amount of mass per unit volume is called its density, and we denote this by rho, where rho equals m divided by v, and its unit is from equation kg per meter cube, or if we just want to use the CGS unit, then the unit of density is gram per centimeter cube. Both the units can be used according to our criteria, and its dimension is ml inverse 3. And density, another important property of density is if temperature of a body increases, its density increases. That means whenever temperature rises, you know the particles gets extra energy, and then they just leave their own position, they expands, and that means their volume also rises. As density is mass divided by volume, whenever volume is rising, that means density is decreasing. Okay, if temperature of a body increases, its density the density decreases. Temperature of a body may increases means expansion of volume, and expansion of volume means the decreasing temperature. Okay. Another important point is here, water's density at 4 degrees Celsius is standard, that is 1000 kilogram per meter cube, 1000 kg per meter cube. These are the important terms related to density. And our next topic is pressure in liquids. as we have known about pressure, what is the effect of pressure in liquids? If we want to measure the pressure in liquids, we have to use the equation P equals H rho G, where H is the height from the water surface, height of an object into the water from the outer surface. So whenever the height increases, the pressure also increases. Liquid's pressure is just directly proportional to height. From that equation we can say it. And in water, for every 10-meter depth, the pressure increases like the amount of air pressure. Whenever you are trying to do some mathematical terms, you have to remember this point, that is for every 10-meter depth of in water, pressure increases just like the amount of air pressure. Okay, for the pressure of liquid, there is a law given by Archimedes, that is called Archimedes Law, and term related to this law is buoyancy. So at first we just want to know about buoyancy. You already know about it, that buoyancy. What is buoyancy? When a body is immersed into water, it feels an upward force, that is called buoyancy. And at first this property was explained by Archimedes, and from Archimedes law we just get some points here. If the weight of displaced water is more than, whenever we are trying to immerse an object into water, then if the weight of the displaced water is more than the weight of the object of the body, then the body will float. That means for floating, the weight of the displaced water will be much than the weight of the body. Second point from Archimedes law, if the weight of the body is greater than the displaced water, the body will sink. And third one is, if the weight of the body is equals to displaced water, that means the body remains where it is kept in water. And that by this term we mean that if we are trying to immerse an object into water, and then if weight of the body is just equal to the displaced water, then the body will remain at its present condition. Then another important law on this chapter, that is also comes for knowledge based question, Pascal's law. This is a very familiar law related to pressure, air pressure. What is Pascal's law? If pressure is applied on fluid means that can be liquid or gas. Two types of fluid are liquid or gas. That means Pascal's law is applicable both for liquid and gas. If pressure is applied on a fluid, and if the fluid is confined in a closed area, then we can say that the pressure transmits equally in all directions and acts perpendicularly on the surface of that area. That is called Pascal's law. So why is this law important? By applying this law, that means this law is applicable for increasing force. There are some systems, there are some machines that are used maintaining this Pascal's law, that some machines use the property of this Pascal's law, where by applying small force or limited force, if we just increase the cross-sectional area, we can get a huge amount of force from that machineries. So application of Pascal's law is important and very practical, and we have to remember this law just because that these laws comes for knowledge based question. Air pressure, what is needed by the term air pressure? We have to know the term air pressure, because By knowing this term, we can forecast about weather update. That is, most of the times whenever the weather updates are forecast on our TV channels or radios, they just uses the term air pressure for that. So as we go higher than the surface, density of air decreases. As the higher level, whenever we just gets on move on higher level, then density of air decreases. And atmospheric pressure, it is an important term we have to remember for mathematical type question. Atmospheric pressure on surface is 10 to the power 5 Newton per meter square. By high pressure of air, it means air is dry and weather is good. If we want to forecast about what weather, if there is high pressure of air, then it means air is dry and weather is good. The instrument to measure air pressure is called barometer. Specific instrument that uses the air pressure is called barometer. And as we were just saying about the weather forecast, another point about weather forecast is if the pressure in barometer decreases suddenly, that is called depression. Changes of air pressure that thus gives some information about the weather forecast. And finally, if the air pressure decreases gradually, then there is a chance of rainfall. So why as this is an important topic, because measuring air pressure or observing the condition of air pressure, we just can forecast or we just can have some prediction about our weather update. And so it is important, and the specific points are important for your MCQ type question, multiple choice type questions. So try to remember all these points. And next we will just try to know some more points related to air pressure. That is, if air changes from a nearby place of higher pressure to an area of depression. I just want to repeat again. If air changes from a nearby place to higher pressure to an area of depression, a nearby place of higher pressure to an area of depression, there is a chance of storm. So whenever the storm, whenever there is a chance of storm, whenever there is a chance of depression, what is the right prediction about weather forecast, everything can be known from observing the air pressure, from the observation of air pressure. The air pressure, as we have known so many points about air pressure, this is important for us to know that who was the inventor of this concept. The air pressure was first measured by scientist Torricelli. So using his concept air pressure, there are so many uses of it. And then finally we are just trying to know about, or we will just focus on elasticity, another topic that is called elasticity. What is elasticity? After the withdrawal of applied force, the property for which an object gets back to its initial condition is called its elasticity. That means whenever an object is at its present condition, present state, and we just apply some force on it, and the object expands or compressed due to the applied force, then if we just withdrawn the applied force, the object gets back to its original state. The property for which the object gets back to its original state, that is called elasticity. And this property of elasticity is just works on a specific limit that is called elastic limit. Okay, uh, after the if the object just crosses its elastic limit, then withdrawn of applied force, sorry, if we withdraw the applied force, then the object will not get back to its initial state. That means for getting back to its initial condition, we have to maintain the elastic limit here. Then another important law related to elasticity is Hooke's law. What is Hooke's law? Within elastic limit, as I have told about elastic limit, within the elastic limit, stress is directly proportional to strain. So we have to know stress and strain first. What is stress? Stress is just like pressure. That means for changing the state of an object, the force applied per unit area is called its stress. So its unit is just similar to pressure, Newton per meter square or Pascal. And what is strain? The relative change of length or shape by applying for extra force. The relative change of length or shape is called strain. That means if we just consider the change of length, the initial length of an object is L naught, and due to application of force, the change in length is L, then its strain will be L minus L naught divided by L naught. So this change can be done in terms of volume, in terms of shape, in terms of length. So from Hooke's law, we just can write that as stress is directly proportional to strain, then F by A, because stress is F by A is proportional to L minus L naught divided by L naught if we consider the change in length. Then by removing proportionate sign, we can use a constant here. F by A equals y into L minus L naught divided by L naught y, where y is a constant term that is called Young's modulus, and this specific modulus is just only used for change of length. Okay. So if we want to consider another types of change, for example, the change of volume, for change of volume, the constant will be changed here. For the change of volume, our constant will be, the equation will be F by, from Hooke's law, the equation will be F by A equals B into V minus V naught divided by V naught, where V naught is the initial volume and the changed volume after applying force will be V, and here the constant is B, capital B, that is called bulk modulus. That means bulk modulus is only related to change of volume. We have to keep this point on our mind, because for our MCQ type question, what is y, that is Young's modulus, and why it is used for, this is only used for change of length. What is B, that is bulk modulus, and this specific constant or modulus is just used for change in volume. The last topic of this chapter is states of matter. As all of us know that three very familiar states of matter are solid, liquid and gas, and there is a fourth state is called plasma. All of us know about the properties of solid, liquid and gas. Here the two important criteria by which the properties are determined are molecular force and molecular distance. Molecular force is the force due to which the molecules just forms an object. That means all object has some molecules. The force acting on these molecules is called molecular force. The stronger the molecular force, that object is very rigid or if we want to compare here in among solid, liquid and gas, we will see that in case of solid, the molecular force is very high, or highest molecular force is highest in terms of solid, then in liquid, and then in gas. That means if we want to just make relation between solid, liquid and gas, the solid has highest molecular force, then the liquid, and then the gas. And if we want to say about molecular distance, that means molecules forming an object, the distance between them is called molecular distance. So this is just an inverse of molecular force. That means in which object molecular force is highest, on that object molecular distance is lowest. That means as solid has highest molecular force, that means solid has the least molecular distance. The gas has the highest molecular distance, then liquid, and the least one is solid. Okay. And there are some also there are some properties on your book, some comparison among solid, liquid and gas. Just try to review all those topics for your exam. And the final discussion is about plasma. The fourth state of object is called plasma. What is plasma? This is also an important definition for knowledge based question. Ionized gas in very high temperature is called plasma. That means high temperature is a criteria for forming plasma. And a very common example of plasma is our sun. And plasma particles are electric conductors. That means they conduct electricity. And in our tube lights, this using this plasma particles, just the light gets on and we get light. So these are the discussion on the different topics of chapter 5, states of matter and pressure. And we will try to make some or solve some creative type questions on our next class. So today's class is over, and just have a good time on your home, and just have some good preparation. Just try to review the topics, the chapters, the creative type questions again and again. So stay safe, and goodbye for now.